Namaste, my friend, and welcome to JEE Mathematics with Typical Monk. This is class 11, and today we step inside the humble triangle to find out how much it is quietly hiding. Here is something worth sitting with for a moment. 3 sides and 3 angles look like 6 separate numbers, but they are never independent, know a few of them, and the rest are forced exactly every time. Sarah once called this chapter just geometry, until she saw how often it decides the fate of a coordinate geometry or a calculus question further down the syllabus. Today, one idea at a time, we learn the exact rules that connect a side to its angle. Take a slow breath. Let us begin. So what will you carry home from today's class? First, the sine rule and the circumradius. A over sine A equals B over sine B equals C over sine C, and all 3 equal to R. Second, the cosine rule and the projection formula, the tools that link sides directly to angles. Third, the area of a triangle, the half angles formulas, and the M to N theorem. Fourth, the in-radius and the circumradius, the 2 circles every triangle carries with it. And fifth, the G drills, a word problem, a match, and a short answer round. So everything you learned today, you can also score with. Ready? One idea at a time. Let us meet the 4 ideas that carry this entire chapter. First, the sine rule. Every side divided by the sine of the angle directly opposite it gives the exact same number, twice the circumradius. Change the side, change the angle with it, and the ratio never moves. Second, the cosine rule. It links all 3 sides to one angle at once, which makes it the only rule that works when you are given 3 sides and asked for an angle. Third, the projection formula. Each side turns out to be the sum of the projections, or shadows, of the other 2 sides falling onto it. And fourth, the area of a triangle, half the product of 2 sides and the sine of the angle held between them. Sit with these 4. Almost every question in this chapter is one of them, dressed differently. Now look at this triangle sitting inside its own circle, because this single picture carries both headline rules. Vertices A, B, and C sit on the circle. The side opposite each angle carries its locus letter. Opposite A, B opposite B, C opposite C. First, the sine rule. A over sine A equals B over sine B equals C over sine C, and every one of those 3 equal ratios equals 2R. Second, the cosine rule. C squared equals a squared plus B squared minus 2 a B cosine C, and the same pattern repeats for the other 2 sides and angles. Third, the circumradius R itself. The radius of the one circle that always passes through all 3 vertices, never more, never fewer. And fourth, a quiet symmetry. Swap a for B for C and a for B for C all together, and every formula on this slide still holds exactly true. Sine and cosine are the headline rules, but 3 more quietly do the rest of the work. First, the projection formula. Side A equals side B times cosine C plus side C times cosine B, and the same pattern cycles round. Each side is literally built from pieces of the other 2. Second, the half angle formulas, sine of a by 2, cosine of a by 2, and tangent of a by 2, all written using the semi-perimeter S and the 3 sides together. Third, the M to N theorem. When a Cevian splits the base in the ratio M to N, this theorem ties the angle at the split point to both of the smaller triangles it creates. And fourth, the whole point of solving a triangle, given any 3 parts, so long as one of them is a side. These formulas together can find the other 3 every single time. Now let us solve a full problem together, slowly, the monk's way. In a triangle, side A is 5, side B is 8, and the angle between them, angle C, is 60 degrees. Find side C and find the circumradius R. Step 1. Write down what is given. A equals 5, B equals 8, angle C equals 60 degrees, and cosine of 60 degrees equals 1/2. Step 2. Apply the cosine rule, since we know 2 sides and the angle between them. C squared equals A squared plus B squared minus 2AB cosine key, which is 25 plus 64 minus 2 times 5 times 8 times 1/2. Step 3. Work through the arithmetic. That is 89 minus 40, which is 49, so side C equals 7. Step 4. Now bring in the sine rule to reach R. C over sine C equals 2R, so 7 over sine 60 degrees equals 2R, and sine of 60 degrees is root 3 over 2. Step 5. The circumradius. 2R equals 14 over root 3, so R equals 7 over root 3, which rationalizes to 7 root 3 over 3, close to 4.04. Notice the path. Given cosine rule for this side, sine rule for R. The same two rules, used one after the other, unlock most of this chapter. Now look at the second picture. The same triangle, but wearing two circles this time. First, the area equals 1/2 times a times b times the sine of C, or from the three sides alone, Heron's formula, root of sines ice minus b times ice minus C. Second, the in radius r equals the area divided by S, the semi-perimeter, and the circle of this radius, centered inside the triangle, touches all three sides at once. Third, the circumradius r equals a times b times C, divided by 4 times the area, the radius of the one circle passing through all three corners. And fourth, a beautiful inequality named after Euler. R is always at least twice R, and the two become exactly equal only for one triangle, the equilateral one. Now sit up straight. These 5 lines are what JEE actually asks year after year. 1. The sine rule hands you R directly. Take any side, divide by the sine of its own opposite angle, and you already have 2R. 2. The cosine rule is the only tool available when all three sides are known and no angle is given at all. 3. Watch the ambiguous case. Two sides and a non-included angle can build two triangles, one triangle or no triangle at all. Always check before you answer. 4. Match every side strictly to its own opposite angle. Side A with angle A, side B with angle B, side C with angle C, never to a neighbor. 5. Keep the angle measure consistent throughout one calculation. Mixing degrees and radians inside a single formula is a small slip that costs real marks. Let us drill the JEE way. I read a claim, you decide true or false, and if it is false, find exactly where the reasoning breaks. First claim, in any triangle, A over sine A, B over sine B, and C over sine C are always the same single number, no matter which triangle you pick. Let us check. That common ratio equals 2R, and R is the circumradius of that particular triangle, which changes from triangle to triangle. So this is false. The ratio is constant only within one triangle. It is not a universal constant across all triangles. Second claim, knowing all three angles of a triangle is enough to find all three sides. Think carefully. 3 angles fix only the shape of the triangle through similarity, but say nothing about its size. So this is false. At least one side must be known. Angles alone decide the shape, never the scale. Third claim, R equals a BC divided by 4 times the area, and this holds for every triangle, not just special ones. Check the derivation. It follows directly from combining the sine rule with the area formula for any triangle at all. This one is true. The identity holds universally, with no exceptions. A quick match now. Say each answer aloud before I reveal it. The circumradius R matches a BC divided by 4 times the area. The inradius R matches the area divided by S, the semi-perimeter. The area of a triangle matches 1/2 A, B sine C. And side A, found through the cosine rule, matches the square root of B squared plus C squared minus 2BC cosine A. If all 4 came to you before the reveal, this chapter's formulas are becoming yours. Here is a favorite JEE format. I read some statements. You silently count how many are correct. Statement 1. The sine rule links every side to the sine of its own opposite angle. Hold your verdict. Statement 2. The cosine rule can only be applied when one angle of the triangle is a right angle? Think before you answer. Statement 3. The area of a triangle equals half the product of two sides and the sine of the angle held between them. So, how many are correct? Two statements, the first and the third. The sine rule truly does link each side to its own opposite angle, and the area formula is exactly right. But the second one falls. The cosine rule works for every triangle, right-angled or not. At 90 degrees, it simply reduces to the Pythagoras theorem. It does not require it. Now let me save you some marks. Two myths that trap thousands of students every year. Myth 1. SinA can be paired with whichever angle happens to make the arithmetic simpler. It feels harmless, does it not? David used to do exactly this. But here is the truth. Side A is opposite angle A. By definition, always, the pairing never moves, no matter how convenient another angle might look. Myth 2. Two sides and a non-included angle always describe exactly one triangle. Surely the numbers can only fit together one way? The truth, this is the ambiguous case. The very same two sides and angle can be two different triangles, or only one, or sometimes none at all. You must check which every time before you commit to an answer. Time to test yourself, rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the ideas you built today. Question 1. In a triangle, side A is 6 and sine A is 0.5. What is 2r? 6 divided by 0.5, 12. Question 2. If angle A is 60 degrees and angle B is 60 degrees, what is angle C? The three angles act to 180 degrees, so C is 60 degrees too. Question 3. What is the area of a triangle with two sides of 5 and 5, and a right angle held between them? 1/2 times 5 times 5 times sine 90 degrees, 12.5. Question 4. What is the semi-perimeter of a triangle with sides 3, 4, and 5? Add them, 12, then halve it, 6. And question 5. Which angle makes the cosine rule collapse into the Pythagoras theorem? A right angle, 90 degrees, because cosine of 90 degrees is 0. If you caught all 5, you have truly understood today's class. Let us gather the whole class in one slow breath. The sine rule. A over sine equals B over sine B equals C over sine C equals 2r, ties every side to its own opposite angle through one shared constant. The cosine rule. C squared equals a squared plus B squared minus 2 a B cosine C is the tool whenever you have three sides, or two sides and the angle between them. The area, 1/2 a B sine C, or Heron's formula from the three sides alone, is the bridge to both radii ahead. R equals the area divided by S, and R equals a BC divided by 4 times the area, the inradius and the circumradius, in one breath each. Watch the ambiguous case, and always match a side to its own opposite angle. In next class, we step into coordinate geometry with straight lines, slope, the forms of a line, the angle between two lines, and the distance from a point. Do not miss it. And so, my friend, a triangle turned out to be far from simple. 3 sides, 3 angles, one constant that never changes inside it, and 2 circles that fit it perfectly. The incircle tucked inside, the circumcircle wrapped around. Every one of these formulas will return later, in coordinate geometry, in vectors, in problems you have not even met yet. Sarah, David, Lisa, and John all began exactly where you are right now, with this very same triangle. Be patient with yourself. Tonight, revise the sine rule and the cosine rule once, slowly, side by side. One idea at a time. You will card G. Of this I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you among the straight lines.